So we've got a particle moving on a smooth horizontal surface, passes through O with a velocity of 10 meters per second. At time t, it's gone x meters. It's got a velocity of v meters per second, and it's got a force acting on it back towards O of 1/8 of v. And there we are. Okay, now we've got to find the time taken for the velocity goes 10 to 5. Well, this is obviously going to be that A equals either dv by dt or v dv by dx. So it's going to be a differential equation type question. So the first part, I'm going to resolve, and I'm going to resolve, let's have in that direction, because that's the way I'm going in, and I'm going to get resultants equals mass times acceleration. So I really need to put the acceleration in here. I'm taking that way to be positive because I've got my v and it's 10. If I want to go the other way, I'd have to be minus 10 and minus v. So resultant force is going to be minus 1/8 of v. It's no other force because it's a smooth horizontal table, equals the mass, which is 0.4. And I can either choose dv by dt. Well, actually, I'm going to do that one because I want time and it's giving me velocities. It doesn't mention displacement at all in this part. So that'll be dv by dt. So I separate the variables, times both sides by dt, put dt up here. So I want all the v's on the other side, so I'm going to have to actually divide by v, and that'll give me 1 over v. I'm actually going to, because I want time, I'm actually going to get rid of this minus an eighth by timesing both sides by minus 8. And that'll give me minus 3.2 times by that, and that will be, I've got my dv on that side, so dt comes to this side, dv's over that side, dv's, yeah, that's good. Put the integral sign in, and I'm going to put the integral sign in there because it's easier for me, and that'll give me t equals minus 3.2 ln v, don't forget the plus c, and so when t equals 0, v equals 10, therefore we get 0 equals minus 3.2 ln 10 plus c, so c equals 3.2 ln 10. So now we get our formula. I need to write it down. T equals minus 3.2 ln v plus 3.2 ln 10, and I want to know when the time taken for the velocity to get down to 5. So when v equals 5, t equals minus 3.2 ln 5 plus 3.2 ln 10, and now I can see, to get its exact value. I'm surprised it hasn't asked me for the exact time, because I've got ln 5 negative and a plus ln 10, so it's going to be rules of logarithms. So I'll do it slowly. I'll take out the 3.2 to start off with, so I get 3.2, and that'll be minus ln 5 plus ln 10, and that will be t equals 3.2. Well, it's the same as ln 10 minus ln 5, so it's going to be divide, so that'll be ln 10 over 5, so that will give me t equals 3.2 ln 2, and that approximately equals 2.2180709, etc. And that's the first part done. I'll do the second part in red up here. And what have we got now? We've got to work out the average velocity. So the average velocity equals the total distance, or total displacement actually, divided by the total time. And I've just worked out the total time. That total time is that is the total time there, 2.218. So I've got to work out total displacement. Now, if I had to work this bit out, this formula out here, if I've got v equals some function of t, then I would have done dx by dt is velocity that equals some function of time, and split it up here. But I didn't, and so, well, actually not that one, this one here, obviously, but I didn't do it like that, so I'm going to try it again by using resultant forces mass times acceleration. So I'm going to resolve, I take that way to be positive, and so resultant force equals mass times acceleration, so I get minus 1/8 v equals the mass, which is 0.4, and this time the acceleration I'm going to use v dv by dx because I'm interested in displacement. So that will be v dv by dx. Well, that line is a bit long there, let's just get rid of a tiny bit of that line. V dv by dx, and now actually you can see that the v's cancel out, and I'm going to multiply both sides by dx, and so that's going to give me dx times everything through by minus 8, so that'll be minus 3.2 dv, and then I'm going to put in the integral signs, so the integral of that, and that will give me that x equals minus 3.2 v, don't forget every single time, plus c, and so when x equals 0, we're told that v equals 10, so 0 equals minus 32 plus c, so c equals 32, so x equals minus 3.2 v plus 32. And now I need to find out the time taken, so I need the displacement taken going from 10 when x is 0 to 5. So when v equals 5, x equals minus 3.2 times by 5 plus 32, and so x equals minus 16 plus 32 is 16, and therefore average velocity equals total displacement, that is 16, over total time 2.2180, etc., and that equals 7.213475. Obviously 7.2123 significant figures, and that is meters per second. And that's question 4 done.